All righty, if you can hear me, we'll just be waiting another minute or so before we get started. But good morning, good afternoon, good evening, depending on where you are. Welcome. We'll be getting started shortly. If you are out there, take a second to locate the chat box that should be, well, probably beneath or to the side or to one of the other sides, depending on whether you're on mobile or desktop or how big your window is. But take a second to find that and give us a shout out. Say hi. Again, we'll be starting in just a minute. Hey, Mark. Hey, Trudeau. Long time no see, Mark. We're going to have to catch up soon. All right. We are a couple of minutes in, and it is time to get started. I will start with a little bit of introductions to TWIML, then we'll get to introducing Luigi, and then jump into our content for the session, which is focused on Amazon SageMaker. But before I, start introducing everyone to TWIML, Luigi, say hi.
How you doing, Sam? Great to be here with you.
Awesome. All right. So for those of you who are not familiar with TWIML, we are all about making ML and AI more accessible to our listeners and their communities by really sharing and amplifying a broad cross-section of voices from the ML and AI communities. That is what we are all about. And a lot of people think of us and know us as a podcast, but really what makes TWIML so special is the community that's formed around the podcast. At its core, this is people, members, folks that share a common interest in learning about machine learning and AI, sharing what they learn with others, and just helping us all increase in our knowledge and understanding of various things that we're interested within the ML and AI umbrella. We do that via a variety of forums that includes meetups, such as we've got a Kaggle meetup, for example, that includes folks that are working together on Kaggle competitions. It also includes study groups, which we'll be talking quite a bit more about today. But these are groups of folks that come together to learn things. We've helped hundreds of people through online classes like the Fast AI courses over several years. And as part of our broader commitment to education, we've started really over since the beginning of this year working with course creators like Luigi to help bring their courses to our community and incorporate the study group model, because what we found is that community-based learning, where we're all learning together, has been super effective at helping folks, stick with courses and complete them and get a ton of value out of them. We have a Slack that is 4,000 or so people strong, that is very active, and I encourage you to check it out. And the way to join this community is via twimlai.com/community. It's totally free, and once you fill out the form there, you'll be invited to the Slack automatically. So that is a little about us. Again, I'm Sam Charrington. I am the founder of TWIML and the host of the TWIML AI podcast. But the star for today is Luigi, who is going to be, I'll be speaking with about his course and experiences with Amazon SageMaker and getting models into production. And so let's start there. Luigi, tell us a little bit about your background and how you came to create this course.
Sure. Thank you very much, Sam. And before we get started, I just want to thank everybody for joining us here today. I'm extremely excited to be launching my course, and I'm very grateful to everybody who is giving up some of their Saturday to be here with us. So I'm happy to say a bit about myself. I'm the founder of mlinproduction.com, which is a blog I started in 2019 with the goal of helping data scientists, ML engineers, product managers, and other data practitioners build real-world machine learning systems. And what led me to start the website is my career as a practitioner, one, and my love for teaching and explaining technical concepts to people. So on the practitioner side, I really consider myself to be a full stack machine learning person. And currently I'm the director of data science at an educational technology company called 2U. And what I do there is lead a team of data scientists, ML engineers, and product managers building end-to-end machine learning systems and products. And before that, I was an individually contributing data scientist at 2U. And prior to joining 2U, I held a variety of roles all across the data spectrum. So right before 2U, I worked as the first ML engineer at a company called Control Labs, which was recently acquired by Facebook. And before that, I worked as a data engineer and as a data analyst at numerous other startups. So working in each of these different roles has really given me a bird's eye view of what it takes to build not just machine learning models, but machine learning systems and products. But it's my love for teaching and explanation that actually drives me to share that knowledge with people. And I've designed and implemented actually several graduate courses in data science, and I'm super excited to finally be teaching online.
Tell us a little bit about the courses that you've done previously. What were the focus of those courses?
Sure. So I actually taught at Fordham University, which is also happens to be my alma mater. And specifically, I was teaching in the master's program of computer science. So it was mostly technical students, but many of these students were actually transitioning from careers that might not have been technical. So one of my students was actually a producer on CBS. Others were individuals who were working at Con Edison, which is the energy utility in New York City. And the two courses that I taught there, I designed and created the curriculum for both of them. One of which was a big data engineering course, which was focused on how to actually build underlying data architectures for companies that are going to be ingesting massive amounts of data. And the other course I taught was a practical data analysis course, which was really focused on teaching students how to actually analyze data and answer real-world questions. And in both of these courses, I really made the emphasis to be able to learn skills that you can apply in the real world immediately. So my goal wasn't to teach theoretical concepts like, law of large numbers and central limit theorem, but it was really to equip students with the skills so that they can go out in the real world, analyze data, and build projects immediately.
Cool. So we'll talk a little bit more about your background as we dig into the conversation. But before we get too far, we thought it would be interesting to learn a little bit more about those of you who are in the audience. So if you would take a moment to visit the URL that is on this screen, it's pollev.com/teamtwiml758. And answer the question here: which option below best describes your interest in Amazon SageMaker? Again, the URL is up at the top of the screen. And it looks like the URL is also in the chat. Thanks, Jose, behind the scenes, for dropping that in there. We'll just wait a few seconds to get some responses in here. Looks like we've got a handful. And we're showing the responses here. This is live. You can continue entering your responses. Looks like we've got a pretty good mix, Luigi.
For sure, for sure. I wouldn't have expected this distribution before the call started.
What would you have expected?
You know, I probably would have seen the career option sort of really by far be the number one. And then I'm not sure how the spread would have been amongst the other three, but it seems pretty, fairly distributed across at least two choices. So it's like bimodal. And then the other two options still have, a decent fraction of all the users. So pretty interesting.
Yep. And it looks like I saw at least, there you go. Some of the distributions changing. So this is again live, but we are going to move on. It was great to get this insight into where folks are coming from. Where we want to start this conversation is around the challenges of running real world systems in production, because that's where ultimately you will see the benefits of a system like SageMaker. So Luigi, tell us a little bit about your experiences in this area, and what are some of the things that people need to be thinking about, as they're moving from developing models to getting them out into the real world?
Sure. So part of why I love my job is because it's super challenging, right? Building production ML systems that work reliably in the real world when you're faced with messy data sets is super hard work. And I think researchers, students, and ML hobbyists, like people who participate in Kaggle competitions, they understand how difficult it is to build a really predictive model. But it's hard to truly appreciate how difficult it is to build a working machine learning system unless you've actually had to build one yourself. And an example I really like to use is Google Smart Compose, which is the Gmail feature that suggests auto-completions for your sentences. Most people would agree that Smart Compose is an amazing feature, right? It feels almost like magic when you're using it.
And it seems like it's getting better and better.
Absolutely, right? And that actually leads into our discussion about production ML systems, right? We want the systems to improve over time. We don't want them to be static things. But there's a real difference between the Smart Compose feature that users see and interact with, which is built on top of a production system that has to be super reliable and serve hundreds of millions of people, and the machine learning model that actually powers Smart Compose, which is responsible for predicting the next words in a sentence, right? So machine learning knowledge is required to build Smart Compose the system, but it's definitely not sufficient on its own. So for instance, figuring out the best model to use doubtlessly requires training many models over entire clusters of compute resources, right? This couldn't have been done on a single server or on a single laptop. And in fact, this really couldn't have been done by a single data scientist. And when you have multiple data scientists working on a project, you really need a systematic approach to keep track of all your experimental results. And these need to be stored in such a way where it'll be easy for you to query and understand which of the best models was built and be able to compare experiments that were run by different data scientists who most of the time use different frameworks and different methodologies, right? So I call this the experiment management problem. And when you finally do arrive at a model that's appropriately predictive for your problem, you need to actually deploy this thing in the real world, right? And the skills that are required for deployment are very different than the skills required for actually building the model, right? When it comes to deploying your models, you need strong software engineering skills, and you especially need to know how to build APIs that are reliable in web services. But it's not just enough to, build a simple web service. I see a lot of blog posts about standing up Flask applications, but that's not going to get you all the way there, right?
Sure.
Smart Compose is used by millions of people. So your system better be able to automatically scale with the demand that comes from increased users. And being able to automatically scale requires DevOps knowledge, right? And throughout this entire process, we've been talking about a system that moves, I'm definitely willing to say on the order of petabytes of data around all over the world. So it certainly doesn't hurt, to have some data engineering chops here. So I've managed several different skill sets that you should have, or that you'd like to have, namely data science, data engineering, software engineering, and DevOps. And of course, you don't need to be an expert in each of these areas, but this wasn't always true. Just a few years ago, if you didn't know how to do these things manually, you wouldn't have been able to do them at all. But today, you can really rely on some technology that's come out to help augment your abilities.
Yeah, so this conversation brings to mind a tweet that I saw just earlier today that was along the lines of, hey, a lot of people are trying to kind of jam software engineering principles into data science, and that's wrong-headed. That's not the right approach. And as you would expect on Twitter, that was a controversial statement, and the thread ensued. But there are two sides to this issue, right? In the experimental phase of data science wants to be kind of inherently unstructured in some ways, but then it's surrounded by all these other things that want to be more structured. And I'm curious if you've got any experience in your, the various teams that you've worked on and with, of how this process has evolved over time from, unstructured to structured, and what you saw as a result.
Sure, that's a great question. And I've actually been thinking about this a lot because now that I manage teams doing data science, the metrics that I'm measured on are very different than those I was measured on when I was an individual contributor. And you're right, data science projects can oftentimes be thought of in this two-process approach, where the first phase is an exploratory phase, where you really don't know what you're going to be able to predict or model until you actually run the experiments by themselves. Now, something that you said that I sort of disagree with is that the process needs to be sort of, not systematic or sort of more randomized, not as much of a strict process around it. I think it's true that it's hard to plan out what's going to happen in the research phase, but we can sort of implement certain processes around that to make sure that we're being as efficient as possible. Although it has to be said that we don't know whether the models that we're going to train are going to actually be predictive. And then there's this transition where you go from writing this sort of experimental code that you don't really care if it scales, you just really want to iterate on your ideas as quickly as possible, to then the sort of production phase where things need to work reliably, safely. You need to have fault tolerance built into your system. There's an entirely different set of constraints in this phase of the problem. And this is where principles from software engineering, DevOps have a larger say in the matter. But I would agree with you that, we can't just fit data science project, completely into the framework of software engineering and vice versa. Mm-hmm. But if there's one thing we can be certain of, as you said, is that if you post something controversial on Twitter, you're going to have a thread that ensues, and people take all kinds of sides very quickly.
Yeah. And so, what we're, I think, alluding to here is that there's a role for both kind of a structured process as well as technology to help make this data science problem, this end-to-end data science problem, more more efficient. I've written about this extensively in ebooks like the Definitive Guide to Machine Learning Platforms, including the experiment management challenge that we've talked about, and deployment, data management. I'm curious your take on this. What is the role of technology in helping folks solve this problem?
Sure. So today there are a host of ML platforms that are available to help data science teams build their ML systems. And these platforms are built to augment the skills of the actual individual data scientists, so that you don't need to be a software engineer, you don't need to be an SRE. Rather, you can just become significantly more effective at your job if you know how to use the platform really well, right? So the new abstraction is knowing how to use the platform very well, rather than being a professional software engineer and being a professional DevOps SRE and being an ML engineer, right? So get to know the platform well, and obviously choose a good platform, and you'll be significantly more advantaged when you're actually building these systems. And another benefit of using a platform, and this is especially important for managers and leaders of data science teams, and I'm really excited to see that in our poll earlier, there was a large number of people who are thinking about using SageMaker within their teams and leading teams using it. It's significantly cheaper to buy a platform today than it is to build your own. So if you're running a data science team, you want to be spending your time on providing differentiated value to your company by actually building predictive models, right? You don't want to spend money and effort building essentially commoditized software today. And trust me, I know this because I've built multiple ML platforms at several different companies. And in fact, Sam, you brought up your ebook. During my talk at TWIML in 2019, I spoke about an ML platform that I had designed and built in one of my roles.
So there's a bunch of interesting questions that that come up here. We'll be talking about SageMaker in just a moment, which is an end-to-end platform. There are also lots of point tools that are available to solve specific aspects of, or to address specific needs of different parts of this process. I mentioned experiment management as an example, deployment as another. There's a spectrum that starts from kind of building your own platform from the ground up, and ends at kind of choosing something that's off the shelf. But there are lots of points in between where you can integrate different tools, either open source or homegrown or commercial. Before we get into talking about a specific example, again, SageMaker, what's your take on how to choose the right approach in selecting a point in that spectrum to operate on?
Sure, I think that's a great question. And I think you can really think of it along maybe 2 or 3 different axes. One is the skill level of the data scientists on your team. The other is how specialized the problems that you're working on are at your company. So let's stick with those 2 for the time being. So in terms of your team, if you have people who are really experienced at learning how to use many different tools, right, and who can quickly adapt, then it may make sense to use sort of a suite of different ML services. But one thing I've found on my teams, at least, is that introducing a lot of new tools to data scientists who already have to know many different tools in order to do their jobs well is sort of a bit of a headache, right? So that's the sort of reason why using an end-to-end solution might be popular, because you can use one thing, learn that thing well. If the tool is built very well, there will be sort of services and concepts that that work across different problems. So that's one thing, right? How good is your team at adapting to new software, and what is the cost you want to incur for introducing different tools. The second is the sort of how specialized the problems you're working on are. The type of platform you need to build a self-driving car is very different than the type of platform you need to perhaps build a recommendation system, do some email optimization, do some lead scoring, sort of, I don't want to say commoditized, but problems that many more companies have and that your typical data scientist will probably work on. In those cases, it's less important to have the super specialized tool when an end-to-end thing may get you most of the way there. And I remembered the third point. The third point, and this is something I often struggle with, is how strenuous is the procurement process at a company, right? If it takes you 6 months to a year to buy one particular tool, well, I don't want to be doing that for 5 or 6 different tools. But if procurement is quick, it might make more sense. So basically, I would say if your problem is really specialized and your data scientists are effective at learning multiple tools and procurement is quick, it may make sense to go with a suite of sort of best in breed tools in each category that you're working on. But on the other end, if one of those conditions doesn't hold, you may just want to go with an end-to-end solution. And an end-to-end solution may make sense if you're just getting started with platforms, and you can choose later on to buy additional individual best-of-breed technologies if that's your goal.
Mm-hmm. Mm-hmm. The first point in your list was skill level, but it's not one-dimensional like that. It's more maybe skill sets in the sense that you may have folks that are incredibly skilled, but not skilled in the types of things, they don't have the types of skills required to build a platform from scratch.
You're absolutely right. Right. Every data scientist is skilled. We're talking about, extremely educated, high skilled people. But in terms of having skills in particular areas, that's where the question is.
Mm-hmm. All right. So we've talked about the challenges that we face in getting models into production. We've talked about the role of tech. You mentioned there are lots of options out there. I've documented some of those options in the ebook. Why SageMaker?
Yeah, that's a great question. So I would say, first of all, one good reason is that it's built by Amazon, right? And Amazon is a company that's been running machine learning systems in production for well over a decade. So any platform built by them is going to encompass the best practices that Amazon has learned for over all of the years of doing this work. And we can be really confident that the design decisions that were made weren't arbitrary choices, right? These should be sort of backed by all of their experience. And on top of all of the experience they have from their own operations, AWS services thousands of clients, right? So they have a treasure trove of user research to draw on about all of the types of problems that data science teams, across industries, across domains could be facing. And they've certainly incorporated that into the actual tool. So that's number one. And number two, I would say that SageMaker really solves each of the problems that I brought up earlier for building production ML systems, right? With SageMaker, the API makes it easy to do things like you can distribute your model training over clusters of compute. And the best thing about this is that you need to know nothing at all about EC2, right? No knowledge is required. In terms of managing experimental metadata and keeping track of the best performing models, you can do that very easily, and it's totally integrated with all of the popular ML frameworks, things like scikit-learn, XGBoost, TensorFlow, PyTorch, and it's super easy to adapt if there are new frameworks that you want to use. On top of that, deployment is super simple, and you can deploy for different use cases. So for instance, if you need to deploy your model for batch inference, which is also known as offline inference, you can do that very easily. If you need to stand up API endpoints, you can also do that very easily. And you can set up these API endpoints so they're completely auto-scaling, right? No DevOps knowledge or software engineering experience is required. You just configure how the models should auto-scale, and AWS takes care of the rest. And finally, this is something that I'm super excited about. SageMaker includes a model monitoring component. And there's been a lot of talk recently about model monitoring, which essentially means figuring out if your model quality is regressing over time which is a concept known as drift, and being able to detect that and then figure out if you should retrain your model or build a new model to replace that functionality. So SageMaker has this nice monitoring capability that is pretty nascent and doesn't exist across many other tools. And that's something that is particularly exciting for me, who runs a sort of machine learning operation where I have models producing outputs that other teams rely on. And we need to understand if those models are degrading in quality.
So your premise was that AWS has a huge footprint, has been doing this for a long time, has a strong technical brand. The same could be true for Google and Microsoft, and they have similar offerings in this space. Have you used or looked at any of those other products, and any thoughts on how they compare?
Sure.
So, no surprise, this is a question that just came up in the chat.
Of course. And I don't have much knowledge of Microsoft's tools, right? So I haven't used the Azure cloud, so I really can't speak too much to those products, although I am a fan of the data science process, also known as like TDSP, which came out of Microsoft and is sort of one way of thinking about managing data science projects. So if you haven't seen that, I would highly encourage the attendees of the webinar to just Google TDSP Microsoft and read into that. In terms of Google, I have actually deployed models on Google infrastructure. I haven't used a all-in-one end-to-end ML platform on Google, so I can't really, the comparison may not be fair, but there's always going to be the sort of argument of Google or AWS. I think you can't really go wrong with AWS. I've used it my entire career. So, that's what I had to say about it. It's not a bad, it's certainly not a bad choice. Mm-hmm. And, you'll often have to make these trade-offs. For instance, is your company already on Google Cloud? If that's the case, it may not be you may not be able to just use AWS SageMaker, and vice versa, right? My company today is an AWS shop. So it's almost impossible for us to just start using Google products because of our relationship with AWS. Got it.
I want to take this opportunity to encourage folks to, like Elias, chime in via the chat and let us know your questions. And I would love to incorporate those into our conversation. We are talking about why SageMaker, and maybe can you just take a moment to talk about the main components of SageMaker?
Sure, absolutely. So one thing I've seen come up a lot is people don't quite understand what SageMaker is, right? Oftentimes, like any other buzzword, people will just start saying, "Oh, SageMaker," but nobody has much of a clue of what it actually entails.
And AWS doesn't, they don't help in this regard. They like to, I've joked before that in some ways they've kind of Watson SageMaker. They've made it this kind of overarching machine learning brand that they threw a bunch of other things under. So it sounds like you're seeing that confusion as well.
Yeah, actually, I've been watching SageMaker for the past few years, and I was actually involved in a vendor demo when it first came out. And I will say that it's significantly more impressive today than it was in the demo that I sat in a couple of years ago.
It is.
So in terms of what SageMaker actually is, right, we can think of it sort of in two different ways. First of all, it's a service-based approach for solving machine learning problems. And these services that you use have an interface that is controlled through a central API. Right? So if you're familiar with the SageMaker API, you can do things like run training jobs, run hyperparameter sweeps, deploy your models, monitor your models. So that's one component. It's the API. On the other side, you have the actual development environment, which is known as SageMaker Studio. Right? And if you're familiar with Jupyter Hub, if you've used a Jupyter Hub before, then SageMaker Studio will actually look really familiar to you because it's built directly on top of Jupyter Hub. But where the difference actually lies is that AWS has built a number of user interface components for Jupyter Hub that essentially plug directly into different SageMaker functionalities. So for example, there's actually a tab where you can inspect all of your deployed endpoints from directly within the Jupyter Hub SageMaker Studio interface. There's also a tab where you can monitor your models, and you can generate visualizations like graphs directly from the experimental metadata results that you've generated in your distributed experiments, right? So this is really powerful. From this API, you can run a distributed hyperparameter sweep, which is spawning all these EC2 instances, installing all of the machine learning frameworks, moving your data around, running your experiments, generating those experimental results. It's then storing those experimental results somewhere where it can be queried, and then directly from within the same Jupyter Hub interface that you're used to working with, you can actually visualize those results without having to move any of the data around, without having to toggle on and off these different EC2 instances. So it's really powerful. And the API that I mentioned has a few different sort of interfaces to it. You can call the API directly from the command line. You can use the SageMaker Python SDK. You can use the Boto 3 Python client. So there's a number of ways to actually interact with the SageMaker API. And of course, you can do all of this from directly within the SageMaker Studio development environment. And in my course, I walk you through setting up this environment, using the API, using the SageMaker Python SDK, so that we really dig into the details of how to use this comprehensive system.
I think this is one of the points that people get confused about. It's easy to look at SageMaker on the surface and say, it's a Jupyter notebook. I know how to use that. Why do I need to take a course? Why is it going to be different than, just running it on my laptop? But it's more than that. And the APIs that you spoke to are, kind of like the bulk of the iceberg that's under the part that we see above the surface.
Absolutely. I'll say AWS really did an excellent job in abstracting away all of the details of those individual services, things like EC2, S3, CloudFormation, abstracting all of that away so you don't have to know anything about the individual services. You can just interact with the API, and SageMaker will take care of the rest.
Mm-hmm. Mm-hmm. So we alluded to this in talking about the poll, but one of the arguments that you make is that this, learning SageMaker or a tool like it, but SageMaker is the one that you're advocating for here, is a great way to differentiate yourself as a data scientist, manager of data scientists, et cetera. Elaborate on that point. What are you getting at here?
Yeah, sure. So I know firsthand how difficult it is to get a data science job or a machine learning job, namely because I've gotten multiple of these jobs over the years. But I have a unique perspective here because I've been someone both who has applied to jobs and been hired, and now I'm somebody who actually does the hiring, right? So I've definitely gained a different appreciation on the hiring side now. So let me first speak to the individual contributors in the webinar who are looking to get hired as a data scientists, ML engineers, or even software engineers or DevOps SREs who are focused on doing more machine learning related work. And this is a point I make often, which is you don't need to be a data scientist to do machine learning, right? Machine learning teams need more software engineers and DevOps now than ever before. So every time I post a position for a spot on my team, I get at least 1,000 resumes from candidates. And this is really not an exaggeration. For each job I post, the HR team has to sift through over 1,000 resumes. And traditional advice to candidates is to do side projects and to post these side projects on your resumes. And while this is extremely well-intentioned, it's super ineffective, right? And the reason it's ineffective is because everybody has side projects on their resumes. So when you're sifting through 1,000 resumes quickly, you're looking to see what stands out, not what additional thing somebody has done that makes them look sort of like everybody else, right? So you need something that really differentiates you from all the other candidates. And it doesn't matter if you're applying for your first data science job or if you're already a data scientist and are looking for a data scientist role at another company. Right? And companies have learned that running these production ML systems requires much more knowledge about software engineering, much more knowledge about DevOps than they previously thought. So being able to say that you have the skills to use a system like SageMaker, it not only differentiates you from the crowd, from the 1,000 other resumes, but it gives you the skills that companies are most looking for, right? So this is extremely powerful. And again, I say this and I know this because I hire data scientists. Right. And I can also speak to the individual contributors in the room who are looking to become leaders. One of my favorite quotes is from Marshall Goldsmith, and he says, what got you here won't get you there. Meaning, what you're going to need to be effective at today in order to take the next step is different than what you needed to be effective in your previous role. Right. So the types of problems that you're going to face as a manager are entirely different than those that you faced as an individual contributor, right? You need to think about things like reliability, interoperability, scale. You need to be able to manage the output across teams of data scientists, right? As a manager, you're not going to be measured on how predictive your model is, right? You're going to be measured on how reliable the products and services that you build are. So SageMaker provides an excellent mechanism for doing this and doing this efficiently and keeping your costs low, right? You don't need to hire an entire software engineering team to build an end-to-end machine learning platform. You can just use SageMaker.
I've seen different perspectives in data science teams. The majority, I believe, are increasingly specializing so that they can more effectively identify talent and scale. There are a few that tend to look for full stack data scientists as opposed to partitioning out the skill sets into individually more easily hireable roles. Does the value of learning what we're talking about learning here depend on the type of company you're at or the way they think about growing their teams?
No, I would say absolutely not. In fact, I think it may be even more useful in some of those larger organizations where you have a specialized skill set. And the reason is, and it's something I actually follow in my career, is that you often differentiate yourself more from having an intersection of skills than you do from being an expert in a single skill, right? If you have, let's say, 5 different skill sets, and I'm just throwing a number out there, you're sort of at the 80th percentile in each of them, you're definitely sort of at the 99th percentile in the intersection of them, right? So being able to sort of be a jack of all trades is extremely important. And it allows you to, for instance, be somebody who can communicate across these different teams. And that's extremely valuable to organizations because it's hard to find these people who can sort of transition from one team to another and be able to speak the same language. And this was super important for me when I was at my previous company at Control Labs, where we had, PhD level neuroscientists from Columbia, Caltech, Harvard, this caliber of research scientists. And we had engineers who had held the highest roles at Microsoft. But one of the problems we had is it was really hard for the engineers and the research scientists to be able to speak to one another because they spoke an entirely different language. I excelled there because I had the math chops to at least be able to speak to the research scientists, but also the engineering to be able to, speak Agile, speak Scrum to the engineers. So, and I think that's only going to become more important as time progresses.
Great. So let's talk a little bit more about your course. Can you walk us through the way you've organized it?
Absolutely. So the course itself is structured around pre-recorded content that students will review asynchronously on their own time, and then a weekly study group. And the pre-recorded content includes lecture videos and Jupyter notebooks that contain code samples that demonstrate how to use the SageMaker API and the SageMaker Studio development environment. In my videos, I walk students through setting up the Studio development environment. So have no fear if you're unfamiliar using the AWS console. Even if you are familiar with it, it can still be fearful at times, that's part of what you'll actually learn in the course. In terms of the study groups, each week we're going to meet at this same time to review the week's content, and I will be answering any questions from students. And these questions can be on the content itself or on any other aspects of building production ML systems. And it's my promise to students, and I take this very seriously, that if I can't answer your question on the spot, I will tell you that, and then I'll find out the answer for you, right? I mentioned earlier that I love teaching and that I've taught graduate courses in data science, but it's worth expanding on this just a little bit. When I teach, I really strive to make the information as applied as possible, meaning that when you walk out of each online lesson and out of each study group, you're going to walk out with knowledge that you can apply in the real world immediately, right? In each lesson, in each live session, I inject plenty of examples from my own career about challenges I faced and how I went about solving those challenges. And I'm really not worried about telling you what went wrong, right? Because plenty of things went wrong. I failed numerous times, and I want to be open about those things because I think you learn way more from mistakes than you learn from what went right. Right. So therefore, think about the course not just as an opportunity to learn about SageMaker, which I promise you will learn very well, but as an opportunity to help to learn how to build machine learning systems from someone who has done it for a number of years and continues to do it today. All right, and the last thing I really want to say, and this is probably the most important thing I want to say for students considering taking the course, is that I know that students are at different levels. And not only is that okay, but it's welcomed, right? I think students who are at different levels are actually extremely important for people to improve their learning, right? Experts can really learn a lot from beginners and obviously vice versa. So I meet students wherever they are, right? There's no question that's too basic. And I really strive to make sure that everybody feels welcome and is, excited to come to the courses, excited to do the lessons, excited to come to the study groups, and, feels like they took away a lot of applied, useful information out of sort of each second they spend with the material.
Great. And there are a couple of different options available for the course. Actually, two of which we're highlighting here. Can you talk a little bit about the various course options?
Sure. So I'll start with talking about the pro option here. And the pro option includes 6 study group sessions, right? And in each of these study group sessions, we're going to review the content from the 6 chapters of lessons. It obviously includes access to the pre-recorded lectures, and it also includes access to all of the Jupyter notebooks and the code samples and data sets that we'll be using in the course itself. That's the pro option. The premium option includes all of those things, but it also includes 5 additional lectures that I recorded, which really contain advanced material, things like automation on how to use SageMaker, things like A/B testing different models that you deploy to production. So super important topics that you'll definitely be using in the real world. And finally, it also includes a single session of a one-on-one consultation with me privately. So of course, in every study group session, everybody should feel comfortable asking any sorts of questions, asking about production ML systems, asking how to sort of adapt the things they learned directly to their job. But if there are questions that you really want to dig into independently, you'll have an opportunity to do that with me in the one-on-one consultation session. And the final thing I want to note is that we have an early bird discount that expires tonight at 11:59 p.m. Pacific time. So if you buy within that time frame, you'll have an opportunity to save $50 on the pro offering and $110 off of the premium offering full price. And not only that, but I'm also extending a 10% discount on top of the early bird discount to everybody in the TWIML audience. And you can access that discount by using discount code TWIML at checkout.
Great. And we've polled and surveyed extensively folks that have gone through our study groups, and in particular, folks that have gone through our paid course offerings, of which this is, to be clear, the second one that we're launching. The first one that we did was on causal modeling in machine learning, and the feedback we received was conclusive. The folks that participated in the course option with the study group said that they got a tremendous amount of value from it. They learned so much from the other students and the instructor that it was well worth it. But Luigi, there are lots of freely available resources out there for folks that want to learn SageMaker. Why else is this course, something that's worth their investment?
Well, I'll push back against you a bit there on that last point in terms of lots of options to learn SageMaker. There are a lot of one-off blog posts, which you can only learn so much from.
Mm-hmm.
And I think the only real alternative, and I'm being completely honest here, is to read through the SageMaker documentation. Now, the SageMaker documentation in its PDF form is over 1,000 pages long. I know this because I've read every single page, right? And I wouldn't say it's more instructional in how to use each individual tool rather than it is applied to specific problems that you would face, right? So you're right. You can do that for free. And if you'd prefer to do that, by all means, I highly encourage it. Even if you take the course, I encourage you to read the documentation because it'll only improve your knowledge. But if you're really looking for, to be walked through the process with somebody who has not only used SageMaker in production, but has built production ML systems, has built end-to-end platforms, somebody who you can ask these questions to, then I'd say this course is, there's extremely valuable for students, individual data scientists, data engineers, ML engineers, leaders of teams who are looking to learn these additional things and who also want to see SageMaker in the context of real problems, right? It's one thing to learn from an instructor who is specifically creating a course to teach the content, but it's another thing to learn from somebody who's actually done this day in and day out and continues to do this, right? This is not my full-time job. My full-time job is running data science teams.
Mm-hmm. We've got a question from Loretta. What would you say are the base level prerequisites for taking this course?
Sure. Thanks a lot, Loretta, for the question. I would definitely say knowledge of Python is a must, right? If you're sort of a beginner with coding, this isn't the right course for you. Aside from that, I would say you should have some understanding of how to use the command prompt, the terminal, and some base level understanding of machine learning. Now, you don't need to be an expert, but I think it would be more than okay if you've used scikit-learn to at least train a model and do some data analysis. I think I've really made this course accessible for people with at least that amount of knowledge. And if you have any questions about, AWS specific things, I've built the course specifically so that you don't need to have any AWS knowledge. I walk you through the processes. And if you're in the study groups, I'm more than happy to help you, supplement any knowledge that you may not have.
Great. This is an opportunity for us to get some additional questions in. So by all means, if you have questions, please drop them into the chat and we will make sure that they get answered. One of the questions that came up earlier is where can you get more information about the course, as well as link to the enrollment page, and that is here, twimlai.com/TWIML SageMaker course. Just dropped it into the chat again. Henry asks, any experience on creating training data sets with SageMaker labeling jobs?
Good question, Henry. So SageMaker training jobs, labeling jobs is one of the features in SageMaker, but I'm not covering that functionality in the course. If there is interest, I'd be happy to talk through that functionality within the study group sessions themselves. I'm more than happy to do that. But in terms of the pre-recorded content, we're not exploring that functionality.
Maybe can you talk a little bit about is it easy to delineate what you're covering versus what you're not covering? SageMaker is a big tent in a sense. I alluded to this earlier. There's ground truth and active learning stuff and a bunch of other modules that are integrated in, but not kind of core to the SageMaker experience as some of the others. Can you talk a little bit more about that?
Sure, absolutely. So first of all, I just want to call out that all of these details are available on the actual course page. So there you can see each of the things that we're going to cover in depth week by week. But in terms of the actual functionalities that we'll cover in the pre-recorded content, one is the SageMaker Studio development environment. I'll walk you through setting up that SageMaker Studio, integrating with a GitHub repo, and then I'll walk you through the GitHub repo for the course. We'll then discuss how to train models using both built-in algorithms and custom training code with the pre-built Docker images. From there, we'll talk about experiment management with the SageMaker Experiment SDK, after which we'll look at deploying models, both in the batch inference case and in the online inference case in terms of standing up APIs. And I'll walk you through configuring your deployed API endpoints for autoscaling. And finally, we'll talk about model monitoring, excuse me, using SageMaker Model Monitor.
Great. Question from Anu. Does SageMaker support data augmentation techniques?
So first of all, you'd be able to use any sort of data augmentation library if it's a Python library, right, from directly within your Jupyter notebooks. But in terms of specific services, I'm not actually sure. I do not believe so. I haven't seen one. But of course, as you've alluded to, Sam, on a few occasions, SageMaker is a huge service. So there may not be an augmentation service, but if there's enough demand, I'm sure AWS would add one later on.
Great. We're coming up to the top of the hour. Any kind of parting thoughts from you, Luigi?
Yeah. First of all, again, thank you everybody for joining us and giving up an hour of your Saturday. I'm very grateful for all of your time, and I take everybody's time. It's really important to me that you're giving me your attention. I highly encourage you to sign up for the course. I would love to be learning with you. But if you do have any questions that we didn't get a chance to address in this call or on the course website, please feel free to shoot me an email. I'm luigi@mlmproduction.com, or tweet at me at mlmproduction.
Awesome. I reiterate that. Thanks so much, everyone, for joining us for this webinar. I am really looking forward to this course and everything that everyone will get out of it. We've worked with Luigi to pull this together, and it's clear to me, and I think it's probably clear to you, having watched this webinar, that he puts a lot of knowledge and heart into his work in this course, and we're super excited to offer it to our community. So please check out the course page if this is something that you might be interested in. Of course, I'm available for your questions as well. Sam@twimlai.com. Both of us are active in the TWIML Slack, which you can reach via twimlai.com/community if you need to join it, or just DM us, and we'll be creating a channel for this course shortly. But once again, thanks so much for taking some time out to learn about this course offering, and hope to see you on the inside of it.
Absolutely. Have a great weekend, everybody.
Great weekend.